All right, to round this out, let's start with a really simple test. When there's a duplicate, we're just going to do a system.out.println. I'm sorry, when there's a pick, we're going to do a system.out.println to see how many duplicates are out there. So um, we'll do a get all right here of selected dot get number. And so that way, when we run our code, which we know we have duplicates because we kind of forced it to being there, I don't know if I'm going to have perfectly all of them, but at least I can see that my code's generally working. I don't encourage you to do poor testing, but in the interest of time here, especially as you're watching recorded videos, let me go ahead and just show you. So you can see here, when I pick entry 3, I get a whole bunch of duplicates, a whole bunch of duplicates, a whole bunch of duplicates on each one of these. So it seems as though my data structure is working. I'm finding all the duplicates inside of here. And again, I mean, the easiest thing to do is shrink down the number of tickets being created, and that would be able to test it a little bit more thoroughly. But that's not my point right now. If we can deal with that more in class if you have questions or struggles in testing this. Let me talk about the other data structure that can help simplify this process a little bit. The other data structure we can talk about is called a map. And so the map has two things. It starts with an ID, and then the second one is whatever type you want to, which could be a ticket. So you can calculate the ticket in some way. Or what I'm going to actually do is have a list. Oops, I'm sorry. A list of tickets as the thing that gets tracked. And so what's going to happen is for each ID that gets added, I'm going to keep a track of a list of all the tickets by the ID. I'm going to be able to organize them and arrange them by the ID. And that's where a map is super powerful. And I'm going to use what's called a hash map because I used a tree set before. And so the hash map is another structure we're going to learn about the concept of hashing that helps us to really search fast by segmenting our data by some sort of ID and be able to look up that ID very quickly. So what am I... sorry, I have to do a capital B byte here because the map requires an ID and not tickets. I keep doing tickets. One ticket. Track one ticket at a time. We use a list to track a bunch of tickets. All right, so the way we can manage this then is every time a ticket comes in, I can actually not track the duplicates if I don't want to at this point, but I'm gonna go ahead and keep that other list for now. But every time a ticket comes in, I need to see if it's in the hash map already. All right, so I'm gonna have a list of tickets. Ticks. I'm gonna call it ticks. Just it's not that many extra characters. Tickets for this ID. That's the list I'm going to get there. And so this is going to be what did I name that list? All tickets by ID. It's going to be all tickets by ID. I'm going to search for it on the ticket.get number. Oops, not named it number. There you go. So, oops, sorry, .get. All right. So I go to that map structure. And I can say, get me the value that's associated with this byte number that's inside of there. And again, I keep putting tickets. My bad. So I hand you a byte. You return me a list. All right, that's what the basic functionality of this get right there. Now, the first ticket I add might not be out there. So if tickets for this ID, if I haven't added one yet, it's going to be equal to null. So if it is equal to null, I haven't added one yet. And so what I can do is I can say tickets for this ID is equal to a new list. Oops, one too many. A new array list right there. And then, oh, sorry, then I got to put this in the map. I can't forget about that. So all tickets by ID dot put. And so when I do a put for the ID, I'm going to put that list inside of there. So the ID is ticket dot get number. and I'm going to put in the tickets for this ID uh, into that list. So I get it. If it's not there yet, I create a new list and add it in as the list to keep track of those things. It's kind of like, if I've got a piece of paper for every class and I have the attendance for that, if I go to that class, there's no piece of paper there, I start a new piece of paper and I put it on the shelf for attendance for that class. But that's all. That's all that's really saying here. And then we could say tickets for this ID dot add the ticket. All right, and this will automatically get me a list of each of the tickets by ID. So at that point, this get all method, instead of having to do a search, I'm going to copy it out, comment it out real quick. I can very easily say return all tickets by ID dot get for ticket ID. And I don't have to do the algorithm at all for that. I don't have to search at all. I don't have to do a more complicated search. So again, one of the big concepts that we're going to be talking about in data structures is the class really shouldn't just be called data structures. Not they're always called data structures, but it really should be called data structures and algorithms, because every choice of data structure changes the algorithms you use, and every choice of algorithm changes the data structure you use, and vice versa. You can't really do them independently. If somebody says you must use a map, well, that influences your algorithm. If somebody says you cannot use a map, then that influences your algorithm. Um, People don't say that outside of silly tests. But if I run this again, oops, I have a compiler error somewhere. What is my compiler error? Oh, yes, I have commented out one too many curly brackets there. Better. If I run this again, then I get not the exact same answer because the data is different, but if I continue to scroll up here, let me make this a little bit higher, you can see I still get the lists of each of them by ID that comes out. All right, so again, the goal of this was to kind of warm you back up. If you have coded a lot in Java, this might have been super simple, easy. If you've never coded in, no, you had to have coded in Java to get this class, but if you haven't coded in Java in a while, it shakes up the cobwebs in a language that at least you hopefully remember a little bit before we get to C++. Um, I don't need you to struggle a whole lot with this. This is something I want you to get in, and I want you to play with your code. If you have compiler errors, it's okay. Zip it up, submit what you got. We'll talk about the compiler errors. If you have runtime errors, same thing. Zip it up, submit it. We'll talk about your runtime errors. We're not going to spend much time on this. We're going to do it back and forth this week for a few days. Maybe the start of next week if you're interested in it, and then we're going to move into C++. But the great things this does is it wakes us up, reminds us about programming in general. It gets us ready to do some C programming because a lot of Java syntax is very familiar, and it starts to get these ideas of data structures and how we can kind of work back and forth between our data structures and our algorithms as we work. So as you finish this up, whatever code you come up with, zip it up, put all the code back in there, send it off to me. You don't have to use NetBeans. You can use whatever you want to. I'll import your code if I can't see what's wrong without doing it. Take a look at it or make it run. The goal of this is, this is mostly an effort check. Mostly, if you submit it, you're going to be fine here. But I do want to make sure we deal with some any lingering questions or concerns or maybe gaps you have in your knowledge. You might never have used all these data structures, and that's fine. We're going to revisit these data structures throughout this class. It's going to come back. We're going to build lists. We're going to build lists and not just use them. And so don't worry about that. But I thought this is a nice way to kind of bridge us in a first week. So I hope you enjoy it. Let me know what questions you have, and I'll see you in class.